Welcome to the third and final module on functions. Here you're going to learn more about the scope of a variable, the many differences between a global and local variable, along with how to create a static variable, and how to create a function with the same name but different parameter list according to our needs. Currently, you've learned how to pass a variable by value into a function. This time you're taking a look on how to pass the original value by referencing the variable. For now, you've been using local variables. A local variable is a variable that only exists inside the scope of the function where it was defined and will be erased from memory as soon as that function terminates. In some cases, there will be variables that will be needed throughout the entire program. Now let's run through this program. On line 8, num is declared an integer variable and initialized with 1. Then it prints inside the main num is 1. And there's a function call to function print. This function declares num as an integer and initializes it with 2 and prints inside print function num is 2. It returns to its caller and continues to print inside the main again num is 1. In this program we have two local variables, both called num, who don't have any communication between each other since they are in different functions. With a global variable, both functions can have access to the same variable. Let's make num a global variable. To do this, declare it outside any function, and any following function can have access to it. On line 5, we can see that num has been declared a global integer variable, initialized with 1. Now, when we read through the program again, on line 9 it prints inside the main num is 1. And then there's a call to function print. And on line 18, function print changes the value of num to 2 and prints inside print function num is 2. It then returns to its caller and prints inside the main again num is 2. Remember that now num is 2 back in the main, since num is now a global variable and can be accessed by both the main and print function. Global variables can also be constant. Now I've changed line to make num a constant global variable, and like any other constant, the value cannot be changed. This program would run normally, but in the print function down on line 18, when we try to change the value of num to 2, that would be impossible, and the program will result in an error. Keep in mind that a global variable not initialized will be initialized with the value of 0, and avoid using global variables unless completely necessary, because they make debugging and understanding a program harder, and they also make functions dependent on those variables. Another kind of variable is a static variable. A static variable is the same as a local variable, except that when the subroutine terminates and destroys, the static variable stays saved in memory in case you need to return to that function. And when you do, the static variable doesn't reinitialize. It stays with its previous held data. This program adds up numbers entered by the user until it reads a double 0. Let's run through it. Now, in line 8, num is declared an integer variable. Then, in the following line, the message, enter a series of numbers to be added, when you're done, enter double 0, is printed. Then, we have a while that checks the numbers entered to make sure that double 0 isn't entered. If it is at any moment, the program ends. For this example, let's enter the numbers 1, 2, 3, and 4. Once inside the while, there's a call to function total that receives num as an argument. The function total declares an integer variable called total and initializes it with 0. Next, it adds total and num and assigns it to total and prints, your total is 1, enter another number. And if we take a look at the program output to our right, we'll notice that total always equals the previously entered number, because each time the function total is called, it reinitializes the variable total to 0. But let's change total to a static variable. Now, on line 23, total is a static variable, and remember that static variables only initialize once, and the data stored in it is saved till the end of the entire program. So in the program output, we'll see that when the number 2 is entered, it sums it with 1 to make 3. Then we entered 3, and it's added to total to make 6. And then lastly, we enter 4, and when added with total it makes 10. So now we're going to enter 00, and the program finishes, and it's now that the static integer variable total is destroyed. In the previous module, you saw that we can send a copy of a variable into a program by adding the data type of the variable in the parameter list of the prototype. And in the parameter list of the function header, we declare a new variable to receive the argument. Well, another way of sending a variable into a function is by reference. The function call will be exactly the same, but in the parameter list of the function prototype and header, you must add an ampersand after the data type. What this does is that it gives the variable declared in the function header the same address as the variable sent in the function call. This means that the variable declared in the parameter list is not creating a new space in memory, but really just an alias for the variable sent. Any change made inside the function will have a direct effect on the original argument. In this program, I'm going to demonstrate how to use a reference variable. So first, I declared an integer variable called num and initialized it with 5. Then, in the following line, the message, the value of num is 5, prints, and then a call to function change value is done with num as an argument. You'll quickly notice that in the parameter list of the function prototype and function header, there's an ampersand, so the variable value that is being declared will receive the address of num. Then, inside change value, a message is printed and then value is assigned value plus 2. The function terminates and it returns back to its caller and proceeds to print the value back in main of num is 7, and the program ends. And remember, since the variable value has the same address as num, the original value was altered, and that's why 7 was printed in the final statement. If change value were to be called again with a different argument, then the address of that new argument will be given to value. And know that the reference variable value will hold the address of any argument as long as they are of the same data type. In this program, we're going to use multiple reference variables. First, in the main, I declare the variables num, value, and result as integers. Then, there's a function called to getNum with two arguments, num and value. Both of these are referenced, so we add the ampersand in the prototype parameter list and function header parameter list. And remember that in the parameter list of the function header, there must be two variables declared, contain their own ampersand, and be separated by a comma to accept the two arguments that are being sent. In the function getNum down in line 19, it asks for two numbers, and for this example, let's enter 2 and 4. Now, if this were to be done without reference variable, we'd have to call this function twice, once for the first value and a second time for the second one. Returning back to the main, the next step is assigning the returned value of function call addValues to the variable result. addValues is a function with return type integer, so it will return an integer. In this function, down in line 25, there's only one statement. It returns the sum of num and value. The program returns to its caller and prints the following message. When we add 2 plus 4, we get 6, and the program ends. One thing that I want you to notice is that in the addValues function, the variables are not referenced. This is because the values are not going to be altered in any way. So, if it's not necessary, don't give permission to alter them. It will create potential debugging problems later. One choice that we did have was to make either num or value referenced and return the result of num plus value through there. But then, if we wanted to reuse the variable num or value, we'd have to do another function call to function getNum, and only makes the problem longer. Function overloading is when you have two or more functions with the same name, but different parameter lists. What happens is that the time that the function is called, as long as they have different data types and or different number of variables being passed, the compiler will choose the correct one. On the left, if we look at the function prototype, we have three functions called print. The first two only take one variable, but the data types of those variables are different. One is an integer and the other is a double. In the third function, it receives both an integer and a double. So these are acceptable, and the compiler will not result in an error. If they did have the same parameter list, but different return types, the program will result in an error, because if the compiler doesn't know which one to call, then it doesn't know what to return. The program starts by declaring num1 as an integer variable and num2 as a variable type double. Then it asks to enter a value for num1 and num2. For this example, I entered 2 as the integer and 4.1 as the double. In line 14, there's a call to function print with num1 as an argument. The compiler will scan through the functions, and since num1 is an integer, it will select the first one, and the function will print 2 is an integer. In line 15, there's a call to function print with num2 as an argument. This time the compiler will scan again through the functions, and since num2 is a double, it will select the second function in the list, and the print function proceeds to print 4.1 is a double. In line 16, there's another function call to print with num1 and num2 as arguments. This time the compiler will select the print function with 2 arguments, the first being an integer and the second a double. This function will print 2 is an integer and 4.1 is a double, and then it returns to its caller and the program ends. And with this, I conclude the third and final module on creating functions.